Okay, this video shows you how to do the multiple regression in JMP. And the stack lost jump is the data file we'll be using. And it's on Canvas under the data tab. And first thing, you open this. And then you get a data table like this. There are 17 observations. And there are 3 predictors, x1, x2, x3, and there is a response y. What we will do is that we click on the Analyze and click on the Fit Model. Then you need to choose y and click on y. That is the response variable, and you can select these 3 variables, x1, x2 to x3, and drag it to the construct model effect window. Then you click on Run. You'll get the jump output. And these 3 plots are not useful for our inference. Then you can close it up. Okay, so in the output you have the actual by predict plot, what it is. So this is the actual y responses, and this is the predicted y. So if it is very close to a 45-degree line, that means the prediction is very good. And you also have the residual by predictive plot. Here you can find if there's any pattern in the residuals. And in this plot, we don't see any pattern, so that is good. And in the summary feed, again, you have the R squared. So 97% of the variance is explained by this multiple linear regression model. And you have the root mean squared error, which is the SSF. And the mean response is just y bar, and the observation is 13. So there are 17. There are 17 observations. Under the analysis of variance table, you can also see the in the error row and the mean square column. So this 1.569 is the SSF squared, the estimated sigma squared. And this parameter estimates table gives you the estimates of all the parameter intercept, beta naught, and x1, x2, x3 are corresponding to the estimates of beta 1, beta 2, and beta 3. So these are B1, B0, B1, B2, B3. And these 4 are standard error of B0, B1, B2, B3. And this t ratio and this prop greater than absolute value of t are used for the hypothesis testing when you want to test whether any of these one is equal to 0 or not. Okay. And the first thing we want to do is that we want to get this plot. And to get this, you click on the right red triangle here and click on Save Columns, and you save the studentized residuals. Okay, once you have saved the studentized residual, you will see a new column called studentized residui. And you select this column, you will see the header is blue, and then you click on Analyze, click on Distribution. Then this column is selected. Click on Y columns, click on OK. Then you will see this distribution plot. Okay, you have a histogram and a box plot, and by default it is in the vertical direction. And then you can click on this red triangle here, and in the display option, if you want to make it horizontal, you can click on horizontal. Okay. You can drag the window to make it to the size you want. And if you want to get the normal plot, you click on this normal quantile plot. And then you get the normal quantile plot. And in this plot, you can see that all the points are falling around a straight line very closely. So that means that the student height residuals are approximately normal, and which means that the model assumptions is correct. Okay. So the next thing is that we want to get the confidence intervals. So to get the confidence intervals, you want the mu of y given x hat and the standard error of mu of y given x hat. So these two things can be obtained by click on this red triangle and save columns, predictive values. And again, save columns. The standard error of predicted. And then you got these two columns. Okay, and in the example, we're trying to get the confidence interval for the third, for x1 equals 62, x2 equals 23, and x3 equals 87, which is the third observation. Okay, and we find these two numbers, and we plug in the quantile 2.16, and we get the confidence interval from 18.346 to 20.151. And another way to do this is let the jump to calculate the 95% confidence interval for you. So what you can do is that you can click on the red triangle here and save columns. Click on the mean confidence interval. Okay, this gives you the confidence interval for each mean response. And you got two columns for lower 95% confidence interval for mean response and upper 95% confidence interval, confidence bound, and the upper bound for a 95% confidence interval for the mean response. Okay, so by default it is it just gives you a 95% two-sided confidence interval. If you just want a 95% two-sided confidence interval, you can just use that one. And you can find that it is 18.346 to 20.151, which matches with the hand calculated confidence interval. And the one thing you need to know is that this thing. This indeed confidence interval. It is the prediction interval actually, not the confidence interval for the individual mean response. Okay. And what if you want to get the predicted mean response and the standard error of the predicted mean response at an X point where you don't have that in the data table? So here's what you can do. You need to save the other two columns, which is the prediction formula and the standard error pred formula. So you need to save these two columns. And in the jump table, you will see these two columns. And if you compare these two columns now with the predicted y and standard error pred y, they are exactly the same. But if you add a new x1, x2, x3. So for example, now I want to use x equals 60, x2 equals, for example, 22, and x3 equals 86. So this is not in the original data. Then you find that you got two values in these two columns corresponding to the predicted mean response at this x and the standard error of the predicted mean response at these x1, x2, and x3. And you can also get the 95% two-sided confidence interval for that new x point, for the mean response at that new x point by save columns and mean confidence limit formula. This one. Okay, and then in the data, you will see you have two columns, and for the new x, you have the lower and the upper limit. Okay. Okay, and the next thing is the multiple confidence interval for multiple mean responses, the simultaneous confidence interval. So we again use this formula, and for 95% simultaneous confidence intervals, we use, and for this data set, because P is 4 and the F is 3.18, and we will be using this number, 3.57. And we will do the same thing like what we did last time. We will create a new column. We call it lower just call it lower bound. Okay, this is for the simultaneous confidence interval. And in the column property, choose formula. And in the formula, we should use the predicted y, the mu of y given x hat minus 3.57 times the standard error of that predict mean response. Check this one. And we can use predicted y, or we can use the pred formula y. So now I will use pred formula y and minus 3.57 times 3.57 times what? Uh, times the standard error. So we can use this standard error pred of y, or the pred SEY. Okay, and now I will just use the pred SEY because both of them are for the standard error of the predicted mean response. Okay, this is a lower bound. Click on OK. Okay. Then you get a lower bound for the simultaneous confidence interval, and you get an upper bound. Again, use the formula. Then this time it's a pred formula y minus 3.57 times the pred SEY. Oh, sorry, not minus here. It should be plus. Okay. Then, okay. Okay. Then you get a column for the upper bound. Okay. That's all for this video.